We're back live once again. Hello, Dan. How are you?
I am doing pretty good. Now that we're live, I did notice that your audio well, actually say something again.
Hello, Dan.
Okay, now it's all
T-
good. Yeah.
Today I've been working on PCBs, and today we're going to be talking about a little bit of PCBs, but also some WebAssembly and other things. Why don't you give us a rundown of all the things you're thinking about talking about?
Yeah. So, well, I did give you a menu earlier and let you select, uh, so first thing I think that we're probably going to jump into is something I'm a little more equipped to talk about. And so we had a hackathon at Goliath last week. It's a thing we do from time to time. And I happened to be on the way back from the other side of the country. So part of my hackathon was on an airplane, and I unfortunately did not do any cool airplane hacks, which I have seen a couple that are interesting with the in-flight Wi-Fi. But I have been interested in taking some of the experience I've had using WASM, kind of like server side at Goliath, and some of the opportunities we have there, and applying it to microcontrollers. And I know that this is something that other folks have thought of before, and in general, kind of like putting higher level languages on microcontrollers, I think is something that people either want to do or think is interesting. So I had just gotten back from SuperCon and we had been using MicroPython there. So different technically there, but kind of like same sort of goal in some respects. So anyway, I did some work to run WebAssembly on a microcontroller and have that microcontroller talk to Goliath um, by interacting with the WebAssembly module.
For the software dummies like me, so WebAssembly basically takes these higher level languages and actually compiles them down, and then WebAssembly is that interface layer to the actual hardware. Is that right?
So I think the easiest way for me to think about it, at least, and I'm sure there's a lot of great explainers online that do a better job than I can, but I like to just think of WebAssembly as another machine architecture that you can target.
Mhm.
And it just so happens that it's typically interpreted. And so in the let's say in the browser context, which is where a lot of folks have been interested in WebAssembly because you can, write some C code or write some Rust code or whatever and run it in your browser. On the microcontroller side, you need to have a runtime or interpreter that's small enough to fit, with the limitations you have there. And so what we're doing is targeting this uh, machine architecture that this interpreter can then run on the microcontroller. And there's also some other benefits around like how WebAssembly handles memory and how you can do sandboxing to ensure that your WebAssembly modules aren't going to mess with things outside of the sandbox.
Yeah, that's super cool. I mean, I was always amazed that you mentioned MicroPython and CircuitPython, I suppose by extension. That is also interpreted. There's an interpreter running on board as well, right? So that's the interpreter is written and compiled in C to assembly, and then it's just like sitting there listening for Python. Is that a good way to explain it?
Yeah, it's taking Python bytes and executing them essentially as machine code on the microcontroller. One of the things that I'll mention before any demos or anything like that is I'm not actually sure what the performance characteristics are of the interpreter that I'm using. I will say that there are metrics on how much RAM and ROM is required. So obviously, we're going to be using a project called WebAssembly Micro Runtime, or WAMR, that's under Bytecode Alliance, which is the organization that kind of manages WebAssembly and its specifications. And so they've shrunken down an interpreter to be able to fit on a microcontroller, but they also have a number of different modes of execution. So they have interpreted, just in time, ahead of time, all sorts of like different ways that you can, depending on your use case, optimize for running that in an interpreted fashion.
I mean, I don't think we should worry too much about the efficiency nor the capabilities. We're just trying things out right now. It's just a academic exercise right now. I imagine it would be very different for something in production as well, right?
Yeah, it's hard for me to I don't want to say like it's not a production use case necessarily. I'm sure that there could be some really valuable applications,
Mhm.
especially if you're building a connected device with which the user can write custom applications for. So
Mhm.
I know with like Fitbit or my Garmin, for example, they allow users to write applications and have them run on the device. And so that
Mhm.
sandboxing, they're willing to pay a performance penalty there because you're just trying to get a
Yeah.
little custom functionality. But if you're writing your firmware to run on a device, that's going to be deployed in the field, and you don't have that use case, it's somewhat difficult to justify using something like WASM or MicroPython, unless if you just don't have the skill set necessarily to write low-level C or something like that, and this gives you a
Mhm.
nicer interface. In which
Yeah,
case,
I think there's a
if it
lot of
works, it
benefits to
works.
this kind of like faster iteration type things too, and even kind of doing it live, right? I mean, like I forget where I heard about it, podcast maybe, I don't know, like, but like MicroPython actually running on a satellite, and
Mm.
like it was some kind of dynamic. No, that's not the right term, but like basically, you were basically logging in and able to change the logic live, right? And being able to change what you actually needed to do without accessing a bad piece of memory so that you're, crash on the whole darn thing. So I think like it's not a common use case, but I could see there are a lot of benefits. I think about our applications and like having stuff out in the field. You want to change something, it's connected over cellular. Obviously you could push an over the air update, but before you even do that, if there was a safe way to like try a different set of business logic, there's also a lot of interesting things you could do there, because now your AC power meter that controls a relay to turn something else on. It's like you're doing some different characterization, and then you might change the logic of when that relay turns on, that sort of thing.
Yeah, exactly. I feel like that simple business logic is kind of like the case where it could be useful. In fact, obviously at Goliath we have the OTA service, which you can upgrade all your firmware, and we have a lot of capabilities for doing that. We also have like an RPC service, and one of the things I was thinking about is like if you literally just had a very small amount of code, which is what we're going to be executing today, you could actually RPC that onto the device and just like change the WASM bytes that it executes,
Mm-hmm.
which is pretty interesting in and of itself.
Yeah, yeah, yeah. I mean, especially if these are simple machines, it's not like you're going to be changing like the video processing algorithm, right? Of like the stream coming back, but like when the relay flips, sure, why not? How the LED lights up, sure, yeah. Those things are much more, I think, in the realm of this sort of thing for now.
Yeah, absolutely. The interesting thing is, so with WAMR, this runtime that we're using, or this project that has a runtime would probably be a better way to say it. They actually have a socket support. So there's the WASI, which is the WebAssembly System Interface, I believe, is the way that basically you can talk from WebAssembly to like system APIs, essentially. So if you want to open a socket or write to a socket or write to a file, etc., this is kind of like the defined interface for it. So they do actually have socket support. So you could open up a socket through this WebAssembly module you were running. However, and so actually backing up a little bit, when I first started on this hack, I was thinking about adding support for Zephyr sockets to WAMR because it does have a Zephyr port, which we'll look at in a minute. And so I could basically open up the socket and send bytes over UDP to Goliath. But if we're always going to have that same functionality in how we're sending the bytes, right? If we're doing stream or state data or whatever, it's actually a lot easier just to use the foreign function interface to call functions from either in the WebAssembly module out to the C or C into WebAssembly, which is what I ended up doing to make those decisions and actually just do all the networking in C because we already have the SDK, right? So why are we trying to move it in? And it's likely less efficient there, although I don't have numbers on that. So, we could verify.
You're saying you haven't fully characterized the hack project you did last week?
I did not. I was also extremely sleep
Ugh.
deprived. So y'all are going to see some real gross stuff in this hack. But yeah,
Excellent. Let's fire it up.
cool. All right. Well, I am going to do the very scary thing of sharing my entire screen here because we're going to have
Yeah.
to jump around a few places. Let's
To send
see.
Dan some messages on Slack and see what happens.
Luckily, I've been bitten enough times that I usually don't commit the Slack snafu anymore. All right, so we're in Golioth as we like to do here, and this is just a demo device I set up, and I took the PSK and PSK ID, and this is what we're going to use for our example today. So just kind of a simple example. You'll see I was actually testing this out a little bit before we jumped on, just to make sure the hack still worked here. And then I also
what
wanted.
hardware is this, Dan?
This is here. Yeah, I'll go ahead and pull it up here. And I don't have the StreamYard up, so you'll have to let me know if I'm actually adequately getting this in the frame. So I'm using the Nordic 52840 dev kit here. And then in order to get Wi-Fi support, I'm using the ESP32. I think this is a C3. Yeah, C3 module here. So I'm using the AT Wi-Fi bridge here to be able to talk over Wi-Fi with the 52840 on this dev board. The reason I chose this is simply because it wasn't supported in WAMR, or there wasn't an example for it. They actually have an example with the ESP32C3 itself. But, you know, I wanted to verify that I could do this across boards. And obviously, the fact that we're using Zephyr is making that a lot easier. Anywho, that's kind of how I selected that. I've also just had it handy because I took it with me on that trip. So that was another deciding factor. So yeah, and this is WAMR here, the WebAssembly micro runtime. And this VM core is kind of the core part of what we're putting on our microcontroller to be able to execute the WebAssembly. So as I mentioned, we have ahead of time, just in time, and a variety of other, an interpreter, which is the one we're going to be using here today. There's a variety of ports in WAMR to be able to work with different platforms. And so you can see some of the usual suspects. We have ESP-IDF, NutX, Riot, RT-Thread, a bunch of those that we're familiar with. And there is a Zephyr one as well. And there's a sample here, which is I'm heavily adapting from this. So I made it work with a different board. I also needed to do a variety of PRs here because this had gotten a little bit stale. Shout out to the WAMR team because they accepted a lot of stuff, and it was really easy to get these things upstream really quick, which we always like to do.
Yeah.
And yeah, so they have a sample here. It is a little more verbose than what we need to do because it's doing some things that you don't actually have to do anymore in Zephyr because it was using a previous version specific to the ESP32. So we're not going to look too deep into that. If you are interested in how... Yeah, go ahead.
Just at a high level, like, so this is code that is living. So it's in Zephyr. It's like as a module in Zephyr, or
yeah.
Where does it live in the Zephyr stack?
So it would just be a module. Actually, if you look in here at the module file, this suggests that it's in tree in Zephyr, and there's a issue open that's describing pulling it in tree, and that never came to fruition. So I think actually today we're gonna port this to make it work as a Zephyr module out of tree, so an external module, just like we do with the Golioth firmware SDK. Because it's not currently supported, I can go ahead and jump over and show that I have it just as a get some module in here. So I'm just pulling it in, which is a little bit easier. If you don't have the CMake list set up for Zephyr and you try to use it as a module, then you can have some pain. But anyway, this should be easier. Hopefully by probably early next week, we'll have this working as a Zephyr module. So it'll be super easy to pull in. Yeah. Only other thing I was going to mention is to add support for a platform. It's relatively straightforward. There's not a ton of work here. You can just kind of see that you have to define their threading model with Zephyr threads and just implement a number of functions from a header file. This BH platform you're going to see in a variety of places. So they're just implementing that. One thing you won't see, though, and I don't actually know where an example of it being implemented is, but is the sockets. So we don't have support for that right now in Zephyr.
So does this mean then, okay, so if I'm writing, okay, so I'm not going to write any of this stuff, let's be honest. If Dan is writing some Rust code, let's say, and so you're writing some Rust code, you're targeting the WASM architecture.
Mm-hmm.
WASM acts as an interface layer, and then you can then go and redeploy that towards everything that was listed in that setup there. So like, is it like a write once kind of thing where I could write like Rust code once? Not that I could write. Could you write Rust code once and then target it at ESP IDF and Zephyr and when like obviously there's a lot more like there, especially if Rust has some native ESP IDF support I think now. But like, could you use it to go and like retarget to all these different places?
You could, with the caveat that like the interpreter itself, right, needs to be compiled as an application for each of these. But the actual WASM module part, right, you could execute on any of these. So that would be supported. If we actually take a peek in here at what the source looks like, this is still got a fair amount of cruft in it, but I'll kind of walk through what we're doing in order here. So obviously we have our main function down here at the bottom. Do I need to make it a little bigger? Would that help?
A little bigger would be, yeah, it'd work a little bigger.
Is that good?
Yeah,
cool.
Good, thanks.
So then we're just calling this a init function, and we're creating our kernel thread here. So we're going to use this iWASM main. So simple startup here. And let's find where that's defined up here. So here's iWASM main, just instantiating some of our variables up top, setting up the size of our WASM memory. So the way that WebAssembly works is you basically just have a linear memory. So you can think of it as like a byte slice if you want to. And so whenever you're communicating between native code and WebAssembly, you have to have some way to copy between the different memory spaces. And that's what we're going to be doing here. And then I'm just showing one way of this being possible. You can call across the WASM boundary in either direction, right? So whether you're copying,
and this is because memory, it's protected. Is that right? Is that the barrier that you're creating there? Is so that your play code is not getting outside the playground?
Yeah, that's exactly right. So it is fully a sandbox where only it can access that memory and it can't access anything outside of it.
Got it.
So here we're just setting up the runtime environment, and then we're loading a WASM module. The way that WAMR does it for the examples is they basically just use this header here and drop the bytes in an array, which makes it, there's a couple extra steps after you can build the WASM module to do this, but it's just basically kind of an easy way to recompile. So we are loading the WASM module. So the array I just showed you there is basically the WASM machine code bytes, right?
I'm a little lost. I'm going to be honest, Dan.
Cool. Ask me some questions.
I shall. Okay. So first off, let's get some relative sizes here. So you're showing an NR 52.
Mm-hmm.
What is that linear memory space that you mentioned? How big is that roughly? Like just for what you're doing here?
It is configurable. I probably have it way over allocated. Let me see if this is defined in here or in my project conf. My project conf actually has some credentials in it. So
okay, well then that's fine. All right, I'm just kind of trying to get like a relative measure here because I'm like I said, I'm a little out of my depth on all this stuff. But you're creating, so the thing you showed with the byte code,
mm-hmm.
that is WASM. Like what is that actually?
It's just like a binary that you'd load in a different language. You compile your C to machine code. Actually, it's just like the Zephyr bin, right? That we're going to get out of compiling this if you want.
But does that represent the interpreter or something else?
That represents the module, the WebAssembly module that we're going to execute. So we haven't even gotten to that yet.
Got it. Okay.
All
right, keep going then.
Cool.
And okay, people in the comments, we see there's some people watching live. If you have questions, I'm sure you have better questions than I do too. So
no, I think these are great. But basically we're loading that module. and we're instantiating it. And here's where we're setting the stack and heap size for that WASM module. So it is configurable there. And then we're just going to jump into actually running the module here. So this app instance main, this is where I start to bring in some Goliath stuff. So everything we looked at before that was just things I brought over from the sample that WAMR offers. So just setting up the runtime and loading the module. This net connect is going to, yeah.
I don't know if you see the screen, but Jimmy asked, is the WAG repo private?
It is right now. It's actually just local as well. So it is private at the moment, but hopefully blog post coming soon with some of this code in it. So we'll definitely make that available. I'm not doing anything like rocket science here either, but I think it is helpful just for understanding how to set this up with Zephyr as well.
Yeah, I mean, having, if you're what's that called in climbing, where like the first person up kind of sets the things, the little loops.
Yeah.
Rope goes
what
through
is that called? I know the person who's like spotting you is the belay or the belay or what. I don't know.
Yeah.
The trailblazer.
Yeah. You're the trailblazer. There you go.
Yeah. That feels too generous, but perhaps.
You're the person that is blindfolded but walking first.
Right. that feels much more apt here. And like I said, right, there's the folks maintaining WAMR I'm sure could do this much better than I. But so here we're just starting up, and this is from the Golioth samples. We're just connecting to the Wi-Fi here and setting up our Golioth client with the PSK and PSK ID that I put in the project conf. So if we went over here and I jumped out to our workspace, all we're doing is calling things in the Golioth firmware SDK. So if folks aren't familiar with this, they can take a look at our examples. And I actually pulled these, I think, from just the hello one here. So looks very similar, right? We're getting mostly the same thing. Cool. So connecting with the Golioth client. So now we can invoke any functions that we want to. And next thing I'm going to do is look up this function in the WASM module. So actually here.
This is going to be kind of like self-referential, because you could do all this stuff in Zephyr without using WASM, right? That's part of the tricky stuff here.
Absolutely. Yeah. So all we're actually going to do here is ask a function in the WASM module for a string that it wants us to send via Golioth LightDB stream. So you could deploy down a different WASM module that gave you a different string back. So this is just a demo example. You could put some business logic in there and say something like, hey, invoke this WASM module with this data and let it tell me whether I should send the data up or not based on what I give to it. That might be a more real example there. Cool. So let's actually look at what's getting compiled to WASM here. And I just, once again, kind of adapted this sample. So this is the C code. So we are using C, but you could obviously use a different language here. This is the C code that we are compiling to WASM. So when we looked at that array buffer at the beginning over here, this is the bytes of the compiled WASM of this. And so it's defining a single function here, send stream data. It takes a pointer to a character array and the size of that, and it's just writing a string into it that we want to send up over LightDB stream.
So John asked, in this example that's using C, it's just a demo, but a use case would be to add some sandboxing within there. All right.
I'm not sure if I follow the question entirely. So the C that's getting compiled to WASM is executing in the WebAssembly sandbox. So if we compiled a different language to WASM, it would also run in a sandbox as well.
Okay. What about this question? If the WASM code wants to interact with the hardware in some way, does that all go via a WASI syscall type interface?
Yes, unless if there's something that's already like standardized, to my knowledge, and this is where something is like if you wanted to read, from a GPIO or something like that and send it up to Goliath, you would need to do something like in the C code, the native code that's running on the microcontroller. You would need to give some function that could be called here to say like, hey, get some data from this sensor or something like that. Do something with it, and then call the function to send it up. So you can't just you don't just get automatic like driver support in WASM, right? So that you do have to go across that interface. Like I said, WASI is I'm less familiar with WASI, so there's likely some folks who could correct me. But it is giving you an interface into hardware, and so into the system level calls, right? So it's possible that there is a mechanism for accessing things like drivers and whatnot. But I am not familiar with that, so we'd have to see.
I'm just trying to think of a good example here too. Like my brain's still a little stressed thinking about this, right? But like, would it be possible?
Don't get stressed, Chris. It's Friday.
I'm a little stressed, Dan. I'm allowed to be stressed.
All right, that's fair.
Yeah, it's just the kickoff of weekend hacking. Okay, so if you had like a Zephyr system that was just, you had like kind of C spinning in there, reading an I2C sensor, spitting that data into a memory space, and then you gave WASM access to that memory space as well. Is that something? Is that like a use case?
You could copy it into the WASM memory space.
Okay, so you copy it into the WASM memory space, and then like and then within the WASM memory space is the idea that you could like, so say it was like natively spitting out C. Could it be like, okay, now I want to translate to Fahrenheit or Kelvin, but I could do it in any language now? Is that kind of the idea there?
That's a good example. Yes.
Okay.
Yeah. And then you need to either return it via the foreign function interface, or you need to like reach in to from outside, you can reach into the WASM memory space, which actually that's what we're just about to do here. Okay. So importantly, right here, this function is accessing memory in the WASM context, right? This is our WASM module. So if we want to be able to write to whatever this points to, that has to be in the WASM memory space. So we need a pointer to somewhere in our WASM linear memory to be able to then interact with it in the WebAssembly context. So
Zephyr can get at the WASM memory space, but WASM can't get at the Zephyr memory space, like the all-inclusive?
Yeah, I would say, Zephyr memory space or native memory space, right? The memory of
whatever you're on.
Yeah. So actually,
it's kind of an interesting idea in there, because it's almost like, so like WASM is the black box where you can then program something into that black box.
Yes.
And you could do lots of different things in there, and maybe even, and because it's interpreted, it could be dynamic as well. So then you were saying about the remote procedure call, you could push new code to be interpreted down into that WASM black box. So now I want to give it an extra couple of digits of precision on the conversion from C to F. Fine. You could push that code into there. It would still have the same access to the data coming through there.
Yeah, exactly. So essentially just like replacing what we have here in this array, right? Just push something down different, instantiate the module, and then go from there.
Jonathan's asking, to piggyback on my question, why do this in C if you could do it directly? One reason would be to sandbox C code that's from a third party. Oh, that's kind of interesting.
Yes,
so it's like
that's
if I
a great
trust
point.
Vendor code, kind of.
Yeah, that could be it. The reason I'm doing it in C code is because the tooling was readily available here.
Sure. Yeah.
And I actually have I don't know if they popped up here, but I have some half working Go and Rust examples as well.
Cool.
But not enough to show up here. But I think that might be what Jonathan was getting at his original question. I just misunderstood it, perhaps. Cool. But talking about like getting into that WASM memory space. So I'm, instead of just doing a malloc, right, to set up our character array here, I'm doing a WASM runtime module malloc. So basically I'm saying I've instantiated this module, and in the memory space that's allocated to it, I want to get a pointer to somewhere in that memory space.
Okay.
So once I get that, I'm going to pass that pointer. So here you're going to see the arg0 and arg1 that we're going to pass into the function that we call. So we looked up the send stream data function right here. It has 2 arguments. And so now we're creating the character array that points to a location in the WASM memory space, and then the size of that array. And then we're going to pass those to this function that we looked up, right? We looked up send stream data. We're going to call that function across the foreign function interface here with 2 arguments that we've put in argv here.
And just to be clear again, so this is Zephyr that's calling WASM?
Yes.
Right? See, I think this is, I feel like we need to have like little like sign placards we hold up, like who's in charge here at any time, any given time.
Yeah. Well,
Zephyr's
I feel
in charge. WASM's in charge. Zephyr's in charge, you know? Like
I
can
feel
you get
like
your little kite down that's up there and just hold it up when it's Zephyr?
Yeah, I should, but I do think that like if we have the like the memory space that Zephyr is existing in, right? And we take a portion of it and say, hey, this is where our WASM
That's the
memory
black
is.
box, yeah. Right.
Yeah. So what we're saying here is, our code is executing and we're doing, WASM malloc, or I don't know what the full call was, but that is saying, hey, remember that memory space that we set aside for our WebAssembly module? Get me a pointer in there to, a buffer, what we'd say of like 100. So give me a pointer to that.
When you say give me a pointer, is it like is that possible to change that at any point? Like, I guess the thing that I'm running into is like, it feels like all this stuff is dynamic.
Mm-hmm.
And one thing that F Stokes brought up too is like, this is like a microkernel kind of moving towards that sort of thing, which it does start to feel like it's like moving to more and more like an OS style model. But like, if I wanted to then change it later, right? So you're doing this malloc to create a pointer to some memory space. But it feels like that stuff is static. Like the creating the pointer to some area is like, okay, you do that in Zephyr, so that never changes. But it feels like the WASM stuff could change. Is that a fair assessment?
Yeah. So I guess it's like if you ever, like malloc, what's in that place could change, right? So you see, like at the end of this, we'll basically clean up all of this. And so you could have like a dangling pointer, right, to a place in memory that doesn't exist, and that could be a problem, right?
I know that. I knew that one.
Yeah. So yes, we haven't solved that problem. Maybe if we actually had Rust running on our microcontroller, right, and then we could. That's
right, because you can never do anything wrong in Rust, right?
Right, exactly.
Yeah, Rust is just like the answer to everything.
Of course.
Yeah. And if you're watching this and that made you upset, Dan's email is.
If you're watching that and that made you upset, it also made me upset, is what you need to know. All right. So anyway, we're going to call that function, which is going to invoke it. And it's going to take that pointer. It's going to write this message to that location in memory. And then we are going to access that location in memory, which is in the WASM memory space, right? And we're going to use that to send to LightDB stream here.
Got it.
Yeah.
Cool.
And here is where we're destroying that execution environment, et cetera, for the WASM module. So
Chris asks, could you assign the WASM memory region to the memory map peripheral memory on an MCU and manipulate the MCU peripherals directly from WASM?
That is a great question, and I do not know.
For the record, me neither.
Yeah. When we create the execution environment for the module, I have no idea if we have any say. Here, we're clearly not saying like, hey, this place in memory is where we want to place it. That being said, I assume you could do, put it at a different place in memory. So that's a great question, and that sounds like something that I might now spend my whole weekend working on. So thanks for that. That is a super cool idea, though.
Nerd sniped.
Nerd snipe, successful. All right. Well, I think we've done enough explaining here. I've attempted to do some explaining and done a poor job, perhaps. What do you want to say in our message that we send up, Chris? Friday afternoon.
Chris, yeah, Friday afternoon. Chris is starting to maybe get WASM.
Well, all right, yeah. Well,
you don't have that many characters, huh?
Chris WASM.
Can you just start to? Why isn't this dynamically allocated, Dan? Come on.
I am so sorry. This it's how I feel anytime I do a demo, and I'm like, oh, if I had just, and then I remember it's a demo, right? But that's
okay,
that's
so
how
as we're walking through this as well. So you're
Yeah.
gonna run this.
Mhm.
You're gonna compile this now. This is the part that I'm messing up again in my head. So like, so you're gonna go and compile all of this Zephyr stuff because it's not compiled, or you're gonna just.
Yes. So this is just like compiling a Zephyr, any Zephyr application,
any old binary, right?
Yeah.
Right. It's just it's got this little magical region in there.
Right. Exactly.
It's also running. I think one of the problems is that it is running C, because that makes it a little confusing. It's not like what you really should have done, Dan, is I think you asked for suggestions of what language you should do in there. I said Fortran. You should have written Fortran, targeted WASM, and then I don't even know if that's possible, and then targeted the C, because then it's like, oh, that's not C.
Right. That would have made it better. And honestly, the only reason I did not use a different language is because I ran out of time. So a more capable a more capable developer may have done it. All right. So but this is where I was well, let me back up. First thing we need to do is compile that WASM module, right? And then we're going to put it into the that header file, and then we'll compile our Zephyr application, which has that WASM module embedded in it, right?
Okay.
Yeah, if you say so. All right, I'm going to get rid of the one we already have, and there it has this build script here. I'm not going to go through everything we're doing, but basically we're just using their compiler to be able to generate this. So you see it took the C, built a WASM target out of it, and this is our WASM module here as a byte
That's
array.
it? That's the only thing that got compiled down? It got compiled down just to that?
Yeah, well, it's got compiled down to a WASM module, and then it dumped it out into this C character array. Yeah.
So as your C or whatever your target language is gets more and more complex characteristics in there, this byte array would get bigger?
Yeah, for sure. I mean, it's just instructions, right? Instructions and data, just like any program. We're just targeting a different
Is
machine.
that how computing works? Dan, most of the time I'm just soldering, right?
I know. That's why I'm trying to get more like you. Then I wouldn't have to do all this craziness.
We're gonna switch over to soldering soon, so that I feel a little better about myself.
Yeah, absolutely. All right. I'm just looking for our command here that I had lost. All right. So I am going to build this for our 52840. And we do need to specify the build target for WAMR. That's just since it's not a part of Zephyr entry. So I get some warnings because of some silly things. This actually was recently fixed. These are not my responsibility today. And I am going to go ahead and see if I still have
I'm trying to think through some like visualizations too, and my brain is going to like sci-fi novels that I love, and they talk about like in you ever read the Bobaverse books?
I haven't, no.
Oh man. Okay, so Bobaverse, one of my favorite book series, and they talk. It's a programmer who dies and his brain becomes digitized.
Okay.
Highly recommended. And
I'm going to flash this while you're talking, by the way.
Yeah, that's great.
Okay.
I'm just trying to create narrative across and like one of the things they talk about is like, so basically like his brain kind of gets encased in this like computing element, and then there's like a cradle for it. And so like in my brain, the WASM here is that computing unit, and then the cradle is the Zephyr stuff around it. and there are interfaces that you're able to set up, but the interfaces don't change unless you recompile the Cradle unit, which is Zephyr. How did that do?
That sounds pretty good to me, honestly.
All right. I think that's the key thing to me is that you do have to recompile to get different interfaces from the Cradle to the computing unit.
Yes,
right?
yes, that's true.
Yeah.
You can't. Well,
which Golioth does great.
right,
but
right.
but just thinking about like that idea where you said you could potentially ship, so you would be shipping that .h stuff down to the unit. Like, how would it dynamically? How would it dynamically work? Right, you'd have to like.
It could just get a like you're just giving bytes right to the interpreter to run.
Right.
So whether
So it's
they're
just because
compiled
that
in
is a
or
memory space, you would just have some. So in your Cradle unit, right, you'd have like a listener using an RPC, and then that would then load the. It would basically be like an OTA into that computing unit space. Does that
yeah,
sound right?
it would just take the body of the RPC and put it in a buffer, and then instantiate a module for that buffer, and then
Got
do
it.
whatever it wanted with it.
I feel
You
like
made a good.
your expertise with like containers and all that stuff. You're like, yeah, this is just it's all is just containers. You know?
Yeah. I think you made a good point though about the like interfaces being static to some degree.
Yeah.
We are doing this another thing that I'd probably change if I was to do this again is that we are calling this function from our WASM module, right?
Okay.
We're calling a function in our WASM module. You can also export functions to the WASM module and allow them to call the function. And so
Yeah.
that would probably be a better example because we could take, let's say, all of our SDK functions or maybe our LightDB stream function and just call it from inside the WASM module. And that could
Got it.
make more sense, right? Because you have like a well-defined interface that's just our SDK.
Yeah, that makes sense. And so now it's like a playground just for LightDB stream in whatever language you compile down to it. But you have that one window into LightDB stream. And so like you like here's the one thing you're allowed to do. Do whatever you want with it within your little play space, right?
Right, exactly.
It's like the it would be like the dumb waiter out of this one area out to the Goliath stuff, which then would ship it up to the cloud, right? Dumb
Whatever
waiters.
you want.
Dan, I'm just trying to make it real for my stupid hardware brain.
All right, so we did run this. It's not the most exciting program ever. It just invokes that function and then idles. But you'll see the normal kind of setup here. You'll see that we're using the ESP Wi-Fi module. Connects to my local Wi-Fi here. Connects to Golioth. I just log what we got back from calling that function, and then you'll see that we send it up to Golioth, and so we can actually take a look at our stream data here. And hopefully it refreshes here. So 341. So this is the one that just came in. And we can see Friday afternoon, Chris Wasm.
Woo!
And just like that, we've got it.
Nice. Okay.
Cool.
And just once again, so you said that because the way you compile the program, you had Zephyr peeking into the WASM memory space, pulling something out, and then it shipped it to the cloud. Is that right?
Yeah, that's pretty much correct. It's basically just passing a memory location for the WASM function to write to, and then it looks in that memory location and says, all right, I'm going to get that back. We could also like pass a memory location back from our WASM function, and we could look at, it could say, I wrote this in my memory space, go look for it there. So yeah. And
cool.
you can't, I believe it's the case that, sorry, I'll stop sharing. I believe it's the case that you can't pass any dynamically sized things as like parameters, right? So you're gonna have to pass a memory location here. But you can pass, static things like a memory address or a size, or whatever across the boundary. So if you're just doing something like the canonical examples are always like adding two numbers because it's really easy to pass like two 32-bit integers in and return a 32-bit integer back because they're just, statically sized values.
Okay. It's not super exciting to just have adding numbers though, right? That's
Right. We're much more exciting here.
I mean, some of it. So I've heard you and Jonathan talking about WASM for a long time.
Mhm.
I didn't realize. I wouldn't say I still get it, but I'm getting closer.
Yeah,
So
well,
okay.
that's good. We can keep pushing this forward, but the reason I wanted to do this demo is one, like, give folks a taste of what's possible, right? So, like, paint the picture of the universe that we have, and like I said, for most cases, I think that we probably, this is not what we would recommend you to do in production, right? And there might be some special cases, but an example of where I think this could be useful is if someone's just trying to, like, get started, right? And they want to make their device do something with Goliath. Then maybe having, a friendly, like, JavaScript interface is
Right.
a nice way to get started.
Right. And I think the other piece there too would be if the WASM piece is interpreted and dynamic and you can just change it at will, and you had a piece of known hardware, right? Like something like an ESP32 that's like well defined and low cost and available on the
Mhm.
marketplace. Yeah, then you can start to make a really friendly interface to something that's already pre-set up to have all of the Goliath features. And then now you're just pushing code down into
Mhm.
that sandbox area, right?
Yeah, exactly.
Yeah, Jonathan says applets and Zephyr.
Yeah, I'm seeing. I unfortunately did not see any of the screen while I was going there, so I'm saying we had some good comments coming in, but I think you
I read most
covered
of
them
them. I
all.
think I read most
Yeah.
of them. Yeah. Yeah.
Also, I think F Stokes here is from Low Byte Productions, the YouTube channel. Have you seen
Oh,
this?
cool. Yeah.
Great channel. Would
Yep.
highly recommend.
Great.
Given plugs. Would also highly recommend the Amp Hour, of course. Great podcast. I love it immensely.
Yeah. Don't go there. Don't go there for any WASM knowledge. Although you talking about some of this stuff, it kind of makes me think about like. So I have talked to Scott from CircuitPython
Mhm.
about some of this stuff before, and he's the Adafruit work on that stuff. And you and I have talked to some of the folks from the MicroPython crowd, and like it does feel like it's more bespoke to the capabilities of what they're talking about. Like WASM's kind of this generalized interpreter of any kind of code, whereas the
Mhm.
CircuitPython, MicroPython is like, well, we're going to take Python looking code or micro slash CircuitPython looking code, and then translate that down to the hardware level.
Mhm.
But it does seem like kind of similar activities and issues there.
Yeah. Well, I guess maybe like a question for that, and I think I've listened to. I think there's been multiple of those episodes, perhaps, but I'm curious, both in communicating with those folks as well as in your experience, are those are MicroPython, CircuitPython, et cetera, any similar projects? Are those things that you've seen be used in production settings, or is it mostly like, cool, quick home automation or demos and that sort of thing, or badge hacking at SuperCon, right?
But yeah, that's a good example. I mean, that's of where it's super accessible.
Mhm.
There's some. I think it's really about like anything that's like shipping millions of units, probably not. But I'd say
Right.
probably low volume. There's some people doing that kind of stuff. Something where maybe the dynamic nature of it all is prioritized over
Mhm.
other things. So like if you're plugged into the wall, right? I think one of the problems is that running, it's getting better and better each day slash week slash year. But like there is overhead to do this sort of stuff, and I think some of that happens in a prototyping context. Who cares, right? I've got it plugged into
Mhm.
my USB port. But in
Right.
a battery context, maybe less so. But maybe it's still worth it, especially if you have a big enough battery source and you wanted to, you need to ship stuff down. You need to ship different logic down to the device as well.
Right.
So I think it really comes down to your constraints. But like, my Fitbit, like, no, this is probably going to be running, like optimized, super optimized C because, and maybe even hand coded assembly. It's like somewhere along that spectrum,
Mhm.
you're optimizing for lots of different things, usually because of cost or battery or data or whatever it is. So I feel like the circuit slash MicroPython stuff isn't there yet, but I do think it's going to get closer and closer to um, to being kind of not hand coded, but
Yeah. Now,
the
I get what you're
C-level
saying. I guess
efficiency.
like even if it never gets there, I'm certainly not saying it like doesn't have any value. I think that it brings immense value for prototyping or those small use
Yeah,
cases.
yeah,
But it does make me like I guess in working with this WASM stuff, I'm constantly asking the question is like, is this like kind of a losing game to some degree? Because like there is, anytime you start, well, not anytime you create abstractions, frequently when you create higher level abstractions, you pay some sort of cost in the translation there.
yes, 100%.
When you move from static to dynamic, right, you pay a cost in the translation there. And finding that sweet spot of productivity and efficiency is always like the magic thing.
Yeah.
So I think honestly, just like being realistic or like acknowledging that is important when working with any of these projects.
Yeah, and I think if you're really saying to yourself like, oh, we're just we're going to use this interpreted thing for prototyping, but then like there's also switching costs, right? At some point you are going to switch to static. It's like, okay, there's switching cost.
Mm-hmm.
Maybe it's better to optimize your process. Again, like just use a Fitbit example because it's on my wrist. Like I'm sure they could prototype in a lot of different ways, but I'm guessing if they're already building up systems and testing around the end result being in C or lower, why not just start there? And I'm sure they're probably hiring C folks first, right?
Yeah. And I just saw a question come in here from F Stokes. Yeah. I wonder what kind of JIT possibilities there are here. That's a great question. I mentioned this at the beginning and I didn't really dive into it. So we were just using straight interpreter and what I
I
was
don't know the
showing there.
difference between interpreter and JIT anyways. I'm
So,
just in time, right? But
yeah. So it's basically just saying like, if we're executing code a bunch of times, right, we can actually just translate that into machine code and then execute the machine code directly as opposed to interpreting it every time we run through it.
So like one step closer to being static.
Yeah. Well, it's actually like becoming static at that point, right? It's just saying like next address is this machine code essentially, as opposed to saying next address is have the interpreter do something that, is interpreting this instruction. So WAMR does support just in time and a variety of modes of just in time, but it also has this ahead of time compiler, which is basically saying I'm going to take the WebAssembly and I actually don't know all the details of this, so I won't speak authoritatively on it, but there is documentation. But it's basically saying like if we know the WebAssembly ahead of time, right? Like we were doing here, we were rebuilding the entire application. We could just translate the WebAssembly to machine code for the target that we have, right? Because you can transpile something. So you're going from a high level language to WebAssembly, and we're saying we're going from WebAssembly to machine code for the actual target platform, and we just do that at build time. So that's a place where WebAssembly actually, I think, has, I don't know what MicroPython or CircuitPython or other projects support, but that's a place where I'm like, oh, that actually is a very meaningful distance where you're almost getting like native like performance out of no longer dynamic, but dynamic in the sense that you can choose different languages and change them at build time. Yeah.
What I was really thinking, Dan, is people should just really get more proficient with just writing their own machine code and just like why are they layering all this complexity on top and just get out the old hex pad and
I am the wrong person to have this conversation with because you need someone to push back on you, and I am not the person to do it. I am frequently having to be coaxed the other direction. So as I try to write my own RISC-V core and Verilog. So
right, yes, yeah. Shout out to Dan's live streams on a regular basis as well.
They're incredibly boring, so I encourage you to attend and be bored.
Chris Wilson said, I heard people mentioning using micro/CircuitPython for bring up to validate hardware and then switch to C or RTOS later for production. Yeah, I've heard that as well.
Oh, that's a really good point.
Yeah, I mean, it's really nice to be able to, I think what's interesting about that is like, so some of that stuff, so like what Chris is talking about there, it's like validating, using scripting basically in there. Some of that stuff is actually built into shells as well, and Zephyr specific, right? But like in Zephyr, some of the stuff I would probably be doing in micro/CircuitPython is like writing writing code to like exercise an accelerometer. I've got plugged in my I squared C, right?
Mm-hmm.
But in the event, this is a bit of a stretch, but in the event the microcontroller, the accelerometer has a driver in Zephyr,
Mm-hmm.
and I just want to try out that the actual accelerometer's function, I can use the shell with the sensor subsystem, or so I can use the sensor shell, which is on top of the sensor subsystem, and just ping it and say, hey, what's your XYZ right now? And it just spits it back on the command line. Like that is also another kind of prototyping thing. So like that is another thing that's nice there. It's not as dynamic as the REPL, like what Chris is mentioning. But it's kind of I feel like that's an in-between, and at least in Zephyrland.
Yeah, that's a really good point. Like I said, I'm frequently guilty of like trying to go to the machine code or whatever the equivalent is and whatever analogy you want there. And when we were at SuperCon, obviously MicroPython was already on the device, but then we were using C on the Golioth hardware that we had brought. But Mike was using the MicroPython shell, I think, on a Pico to basically talk over the I squared C with the badge. So it's Pico to Pico in that case. And that actually drastically improved our iteration on getting the data that we wanted coming off the badge.
The REPL in that case? Like,
yes,
so it was just
yeah.
just like the Python prompt effectively.
Yeah, exactly. Yeah. And in addition to the REPL, what is so they recommended using Thonny, the IDE.
Yep.
But I never use that because once again of my idiosyncrasies. But I think it's either M remote or MP remote is the tool. But basically, since there's a file, you can have MicroPython with a file system. I could use my local editor over the serial port to edit files in the file system. Like I just like NeoVim. I did like MP remote, like piped it into NeoVim.
Yeah.
It was super cool.
Yeah, the dynamic reloading is also really, really cool. Like, so basically you're editing a file, you hit save, and it just
remote. Yeah.
So super cool.
Yeah. This is Chris also mentioned MicroPython plus WASM and call it from the Zephyr shell. Yeah, that would be really neat as well.
See, I think so. Then when do you turn that off? Right? It's like some people are going to be like, well, I could just use this forever, right? And it's like there's reasons not to do that, but some people might not. I think it's potentially problematic if you're not kind of codifying stuff for later, but I don't know where the efficiency. I guess you'd have to do a kind of a before and after, like do the exact same functionality in C and then try it in MicroPython /WASM on top and plug in like a Joule scope or what's the power profile kit 2, right? Or one of those things to like actually tell how much current draw it's doing. And then Dan, it would be like microamps, milliamps, and I'd be like, I know what's going on now.
Yeah, for sure.
Sort of.
Yeah, I have no idea on the performance characteristics of this, so I would like to explore it more. Although it turns out sometimes we have things to do at work, so we'll see how much I get into it. Yeah. I do promise a blog post though that will get this initial stuff up, and then anyone who is on the stream, if you want to ping me and say, hey, like build this thing, try that out. I am susceptible to giving into peer pressure, so.
He sure is. I feel like I don't know how much we're supposed to tease on the stream, but remember that one feature that one thing we did on Hack Day, I think before you joined the company, but then we talked about making it a feature for dynamic loading of things. Yeah,
I do remember that.
That's my jam. That's what I want.
Yeah.
That's kind of tied into this too. Boy, there's a teaser, huh?
Yeah. Stay tuned for our product announcements.
Right. Now it's on a live stream.
Yeah.
All right, let's switch into KiCad real quick and watch you struggle like I struggle to understand things.
Oh, boy.
I feel like that's not even gonna come close. You're gonna be like, yeah, no, this is just drawing lines on a page, Chris. It's no problem.
Oh, that is absolutely not going to be the case. I have not opened KiCad in well, actually, I don't want to say because you'll be sad.
Yeah, everybody's got their things, man.
I don't even think that I don't think that I've opened this version of KiCad actually. So
What do you got, 7?
yeah, 7.
I mean, that's the thing. I've got a machine sitting next to me that's still on 5. You know,
Yeah,
yeah, it's easy to not update that stuff. There's no requirement, and yeah, if you'd
cool.
like, I don't know what we're looking to do here. If you want to just look at KiCad stuff, I could just pull up something I have. But
Sure. I mean, I have it open. So actually, here's the question.
yeah,
What is so? I think we have 3 options. One, like you just educate me, which would be extremely useful for me. So I'm very open to that. 2 is we pick something that we could design on this stream right now. So like something very small, right? And we design it, and you walk me through it. Or 3 is we think of something bigger, and we just we brainstorm on that and get started, just
I
like
see.
setting up a
It's easier
project.
for future streams, basically, at that point.
Yeah, exactly. I'm trying to learn from you with the content expertise you have. I'm just trying to bring the folks back. So
Yeah, you got to leave them wanting more, right?
right. So I'll leave it to you to pick from those 3 options. What's your preference?
Show me what you got on screen, I guess. I mean, what do you want to build? So you want to be learning more KiCad.
Yeah. I'm closer to 0 than I am to competent, I would say. But so some things that I've been interested in building some sort of like debugger board. So have you seen like the Pico probe thing? It basically just is like uses the PIOs, and I think it runs on FreeRTOS. But you can just use like the Pico as a UART to USB interface, that kind of thing. Building something small like that, which like obviously you can just use the Pico directly, but I'm trying to exercise skills here. Something like that, or something like a macro pad. I think we might have talked about that, like a 3x3 keyboard matrix. That those are kind of like the things that I've been rattling around in my head.
Okay. Yeah, those are common kind of starter projects, that sort of
Yeah.
thing. Yeah, and you and I had talked about that CH32V003 as well, as like a board to be working on at some point. But
right.
Yeah, I don't know, man. Let's see what you got. Oh, this is right. You're gonna have to share your screen again, because this is it does windowing, so it actually opens new windows for each function is a different program that it opens.
I see. All right.
Schematic editor is its own program, basically.
All right. Well, is that what we're going to start with, schematic editor here?
Well, see, now this is what we should have planned beforehand.
No, we got to do it live.
Tell me about that Pico probe. Like, what is that? Do you need something other than the Pico?
You do not. I mean, you need the USB, and you need to expose some of the GPIOs to be able to use the PIO to do whatever you're going to do.
Okay. But then it's just like it would just be connecting a Pico to like a.
It would be essentially making a Pico, putting an RP2040 on a board that looks just like the Pico. So that might not be a great option. It's not very innovative.
Oh yeah, no, the Pico is very cheap. I would just
right. Well, the point is that I'm going to be designing something here, Chris.
Oh, I wouldn't do that.
All right.
Especially because so let's talk about that.
Idea.
So like so the Pico itself, right? So if we look at the Pico, here I have one here somewhere. You probably have one as well. I dropped it, I guess. My desk is a mess, right? So if you look at what's actually on the Pico, it doesn't make sense to try some of this stuff at the beginning of your journey. I feel like, right? Because this has like a switcher on here, so a switcher has inductors and capacitors and things like that. That can cause all kind of craziness. I wouldn't say that at the beginning. Also, the package style of the RP2040, I probably wouldn't do that at the beginning. And then a crystal, or oscillator rather, it's fine. So I feel like that, like the recreating the Pico is not a good starter project simply because of the size of the ultimate components on there. Now, what I would say is something like this. So this is the a Stentis. This is what I talked about on one of the past streams, and we didn't have time to show, or I don't remember what happened. I just
I
didn't
think
show it.
you had to leave. Remember?
Oh, I had to leave. That's right.
Yeah.
And I just actually sent this out to be redone. I just modified some of this for Rev B, and this is I think a decent model for what you're trying to do, because you could take, if you wanted to use the Pico, you could just solder it down, right? That's actually how it's been designed, so that you're basically creating pads here, and then you're adding functionality that then would kind of glue into it. So I would say something more akin to this, and then adding functionality if you wanted to use the Pico, because then you can use, so like this isn't SOIC, right? That's very solderable to start with, and then it's basically learning how to, it's a step down using a module first, instead of going straight to chip down solution, like recreating a Pico would be.
Yeah.
Not to mention, the Pico is at $4, and that's an incredibly cheap deal. Like it's such a good deal.
You're so practical. You're too practical.
Not too practical. I think just a cheapskate, Dan. Just like a hardware person who's a cheapskate.
That's fair. I'm not. It's you are practical in a complimentary sense, not a derogatory sense.
Got it.
I am not practical in a derogatory sense. So actually, just to like dig down a tiny bit more into it, the size of the components, are you saying that would be difficult because of literally like placing them on the board and like soldering them, or it's difficult from like a routing perspective when designing the PCB?
A little bit of both. Yeah,
okay.
A little bit of both. But really, it's just a, crawl before you walk sort of thing. I think. I mean, like I wouldn't normally tell someone to start with a QFN, because even if the layout goes well, then when you're soldering it down, if the soldering doesn't go as expected, are you're making the board yourself, you don't have like a comparison point to like, is it my soldering or is it the board that actually is the problem here?
Okay, cool.
So, what could we do instead? I mean, I would say that keyboard thing is a good one.
Okay.
But maybe we just get that set up and started there. So maybe we start in the PCB editor, because then at least, one thing you might want to do is define, is it starting from someone else's project, or is it just all fresh?
I'd love to go fresh.
Okay.
If you're open to it.
Okay. Yeah, sure. I think so. One thing you have to do then is you have to think about the envelope of the PCB that you're going to make. So like, how big do you want this thing to be, right?
I don't know, pretty small, like three by. I mean, I guess that's not.
You want it to just be the keys, no kind of bevel around the keys. That's kind of the idea.
Yeah, as minimal as possible, I guess. Like once again, like, yeah, I guess whatever's simplest. I guess making it larger actually can be simpler, right? Because you're not trying to fit as much close together. Exactly. So I'm fine with sacrificing form factor for ease of design, if that makes sense at all.
Yeah, I think so. I mean, and that's the other thing too, is that you should. So one thing that I've run into in the past with people that are more software inclined, kind of coming down the stack, is that there's kind of this. For some reason, it's like there's not as much focus on hardware iteration. So like things that I always kind of try and talk to people about is one, plan for the future, but then plan for second rev as well. So like footprints are free. So if you're gonna put down 9 keycaps and you think there's any possibility there's some other feature you want to put on there, put that down, but don't populate it, right? So because you could put down the footprint, but you don't have to like necessarily go and populate that part that you've put on there. You can always add that functionality later. And then 2 is like, you could start bigger and then plan to have like a kind of a shrink stage in the future.
Makes sense. I feel like,
so it looks like you started a schematic and layout, but you, like I said, you have to share your whole screen, I think, or you have to share.
It said I need to create a project, so I just did that real quick. But so you said open the PCB editor first.
Yeah, if we're going to do an envelope, yep.
Cool. All right, let me switch over to sharing the proper thing here. All right. Here
Chris
we are.
Wilson says to add a reset button to the Pico. That's true. There is no reset button.
Yeah.
On the
I
Pico
heard
native.
that is the on the Amp Hour podcast with them about them talking about why there wasn't one.
Yeah, cost savings.
Yeah.
All right, so this is idiosyncrasy of KiCad, which is basically they have a engineering drawing here, but it actually is by space. So I'd say the first thing to do is to select the board layer on the left. I'm going to move you to my bigger screen so I can kind of see it. So on the right side, you see how there's an edge cuts layer, probably like the 15th layer down.
Okay.
So you see you have, yeah. So
Mhm.
you select that, and then now you start drawing. You can literally just start to draw shapes on this layer. So you have to select the line. So that's literally selecting.
Oh, I see.
But on the, see near that straight line near the edge cuts layer.
This one. Yeah.
So now you can just start to make a closed shape. If you zoom in a little bit, you could also see that there's dots on the screen, and that there's you can just scroll to zoom.
Yeah, it is
Actually,
not liking my.
Are you using a touchpad?
I see. No, I was being silly.
Okay, no touchpads. That's a key thing as well. You have to use mouse with a roller wheel. That's very important to me.
Oh, you do not need to encourage me. I've got the big roller here. So
okay, all right, different
different roller. Anyway, okay, so zoom in.
Yeah, so you're just going to click to start the line, and then but if actually I would, before even that, I would right click and then select a different grid size, right? So when you're you don't really have a defined size right now. Oh, it's not capturing your grid. Oh, you keep capturing the window. Yeah.
Let me just switch to full screen.
Yeah.
That's a little bit strange behavior, but
yeah, far be it from me to using KiCad.
Yeah. Strange behavior. Got to get used to it. All right. Sorry for the screen inception. Here we go. That work?
Yep.
Awesome.
So you're currently at 0.1 inch. I'd say, go to half an inch and like literally just make a box. All right.
Okay.
You went the wrong direction. That was 50 mil.
I see.
Go up to the top. Second from the top.
There we go.
Yeah. So now it's basically jumping and snapping to these larger grid points. You can also do is if you hit the space bar and you look in the lower, you have to move the stop sharing window or the hide. You see down there, there's a, so hit space bar, you'll see it zero out for the DX DY. Right now, if you move your mouse, you can see that it actually will give you the delta there, which is really useful.
Yeah.
So usually when I'll start a line, right, so I'll set a 0 point, especially if the grid is like this. I'll set a 0, and then I kind of have a home base to go back to. This is like a local 0 that you're setting up. Gotcha. And now you just click to start, drag the line, click to end. There you go.
So shall I draw a box?
Draw a box, Dan, and
I'll do it.
Thus your KiCad transformation shall be complete. But boom, right. Look at that. So now if you hit Alt-3, you have a box. Look at that. There's your circuit board outline.
Wow. Are we done?
We're done. Yeah. Ship it to JLC. They'll make that for you, which is crazy, but they will. They'll make it for you. You just made a coaster, my friend.
Oh, man.
So another thing that's like really important, I feel like on a lot of boards that it took me forever to add in is mounting holes, right? So like one thing we could do is you can go to the schematic real quick. And maybe that would be where we wrap this up for now. Is if you go to the schematic.
Is there a better way to open it than that?
Right. And then you can hit O and click. And this is just the same dialog as the button, the third button down on the right. Oh, sorry, it's A on the schematic. Sorry, A.
Oh.
There you go. And this is loading up the default libraries. Okay. Now, usually I just search for mounting hole. Just type mounting and you'll start to see. And then I usually choose an M3, which is like a size of a mounting hole. So if you scroll down a little bit, you'll see M3. You'll see a bunch of different versions of M3. Oh.
Oh, sorry.
No. Oh, sorry. This is schematic symbol. My bad. That would be the footprint stage. Yes. So just this is perfect. Yep.
Okay.
And now if you mouse over this schematic symbol, right? This is the symbolic representation of what will be the mounting hole that goes on your board. So now if you mouse over and hit E, which is basically the details page for this sort of thing. Now in here, we could actually go and assign the footprint. So if you go to that footprint field there, and you see how there's a little library. Yep, there you go. Now this is where you're going to go. There's a mounting hole library on the left side there. And then you'll be able to go and actually choose the M3 size. See, and now there's like all these different versions of this. Yep.
Cool.
Yeah, see, some of them are like exposed copper. Some of them, if you keep going down there, you'll see like there's a bunch of different versions here. Some have like these vias through them. I usually just do an M3, but there's different sizes as well. M2.5, right? There's, I think there's imperial units as well.
Cool.
Let's double click there, hit OK. And now copy this 3 times. So just Control C, Control V a couple times.
Should I move them around or? Oh,
yeah.
I see. When you copy it, just copies it for you to.
Yeah, it just gives you yeah. I mean, this isn't so a schematic. You don't need to do like a location-based thing, right? You can just kind of bunch them all in one area. It's not actually. This isn't actually placing them on the board. This is just representing that you have these 4 units that are going to go onto your PCB. Much like a resistor would be in the schematic, or your microcontroller would be in the schematic, that sort of thing.
Gotcha. Cool.
I would make one more.
As you wish. Can you? Okay.
Yeah. If you're, what you see there is when you're clicking, you see how you still have that that triangle there, which is really an op amp. It's showing that it's in like the schematic placement mode. If you hit escape, it'll just go back to just a pointer mode. Yeah.
Gotcha.
So escape is probably my most common keystroke in KiCad.
I might have to do some remaps. Actually, no, I already have. I think my caps lock is mapped to escape, so that'll be good.
Okay. So now I would say hit save on this. So that'll just save your schematic. And then hit F8, which is just going to be this is just going to associate your schematic with your footprint.
Okay.
And because you already have a footprint associated with the schematic symbols, now it's just going to say, okay, I'm going to go put these in your layout now.
Okay. Do I need to check any of these? Or?
PCB. No, you're good.
Cool.
And then close.
All right.
And there they are.
All right.
And so now if you just drop them there, right? And then go back to Alt-3 so you can visualize it. There you go. You got 4 holes. 4 holes in your board there.
We'll have them make this. Now we're done, actually.
Now you're done. That's right.
I'm just going to make a board of mounting holes is going to be my...
I mean, there's actually some limitations. Some board houses, I don't think a lot of the Chinese ones that I use, they'll actually limit like on, because when you're making a circuit board, it's literally a drill going through a board, right? And it's like, so if you had like super, super high density, if you just did vias all the way across, which is just basically drills that then they backplate with copper,
right?
It's a really expensive process for them, and not really expensive, but it really adds up. So like a high via count board, some manufacturers will be like, that's too high, or we're going to charge you more. So
yeah. Huh. That's really interesting.
Yeah.
Yeah. Thinking about, I mean, like, I'm not even there at this point, but thinking about how various decisions impact price as well as an interesting thought. Yeah. Anyway.
So I'd say let's just like literally leave it here for now. I can show you the board that I'm working on just so we can see like the draw.
Yeah, now that we've done owl. Now we're done fooling around with your stuff.
Well, what is that? There's like a meme out there where it's like draw an owl, and it's like circle, and then the next step is just like a fully drawn owl.
Yeah. Seriously though, I do really appreciate the simple walkthrough. It's actually very helpful.
Yeah, so. I think it's important first step. I've been on the hook I haven't made any KiCad videos in a long time. I think since version 5. So it's on my to-do list.
Well, if you ever need a stooge to play in your KiCad videos, I can produce a very authentic one. So,
well, I can do that in the software realm. So
yeah. Well, when we partner up, we'll just be a bundle of incompetence.
Right.
So it'll be
great.
Great.
Yeah.
See, this is much prettier than what I did. So why didn't you have me do that? I'm just kidding.
Right. Why didn't you just start here? This is a board that we've been working on. This is a Rev A. We need to switch this to Rev B. We'll be talking more about this soon. But this is not a normal thing to do with all these different zones, but it's kind of meant as a quasi-educational thing as well. And Yeah, so this will be, this is kind of where we're working towards, right? So like I mentioned, so if I take, oops, that's not what I want to do. Sorry. If I turn off the visualization of all the components here, right? You can actually just see the, oops. Let's do this. There we go. So you can see the kind of like really tight footprints like this. It's not quite the level you were talking about. If you were doing like a Pico, it would be kind of like doing this level, and it's hard to kind of visualize. There's no scale here, but it is pretty tiny, right? So like, yeah, this is kind of like what you would be doing if you were building like a Pico level board. It would all look like this, and it's probably it's totally doable. It's just probably not what you want to be doing for an early board, especially when the functionality doesn't really require it.
Right.
So, and much like like things like this where we have a ESP32C3 on this board, right? It's not worth it for me to go and put down a PCB antenna and put chip down. It's just like the modules are so cheap and abundant. Like, why not just do this? I think that's really what it comes down to for a lot of this stuff. So if you can buy your way out of it, that's the way to do it. So, especially when it comes to RF. I know, but the thing is, like, there's so many more things that can go wrong here that like you'll be down a rabbit hole for weeks and months. And like, and one of the problems there is like, so like just as the RF example, right? You and I have gone back and forth about like, you want to like kind of dive down the rabbit hole and learn all about the RF.
Right.
It's not problematic until you get to the point where like, okay, well, how do I actually know what's working in the physical realm though now?
Right.
The problem there is that the cost to have test equipment that actually lets you peer into the RF realm is so prohibitive that that you just run into a wall then, right? If the test equipment was cheap and plentiful, right? So like if it was like a Wireshark where it was just, open source program, that's a very different thing because you can go peek under the hood, you can learn more about it, right? But there are some actual like cost restrictions in that space because of, I don't know, economics,
right.
the reality of the world,
monopoly. But
yeah, I mean, I guess, but it's just, but like they're making stuff too, right? And they're, So this is a little dev board. This is all based off the NRF 9160 Feather from Circuit Dojo. Jared Wolf has been on our YouTube channel in the past. Took that open source hardware, extended a little bit more, some other functionality, added the form factor that we like, and then this also talks up to the Ostentis, which I showed you using the quick headers here. So
we also got a question here about what secure element you're using on the board.
Yeah, it's the ATEC 608. Yeah,
cool.
Underutilized so far, Jimmy. It's on there because like what I told Dan before, right? Like you put it on there because you're going to use it at some point. I haven't implemented it yet. It's just on there right now. And Chris has been working on this board with me as well. Chris Wilson, who's in the chat, and like there's just stuff that we haven't implemented yet. But when you're making a board, you just kind of put it all on there at the beginning, and then you try and exercise it using something like a circuit. Man, I'm tying it all back together here. Big old arc here. Using something like a Circuit Python or a Zephyr shell to go and validate this stuff, right? So we were turning on LEDs using the Zephyr GPIO shell, and then once you know that that's connected up properly, then you're kind of keep able to evaluating other stuff that you put on the board, that sort of thing. All right, that's all for me. No more sharing. I think I've hit my limit on streaming for today, Dan.
That's very fair. I mean, we're like almost 90 minutes in, so yeah. Well, cool. Well, thanks for setting up and bringing your high-tech studio as well. Your audio and camera and lighting goodness here. I promise that as we continue to do, if you continue to do these with me, then I will improve my camera and lighting setup. Except for
I'm just gonna drive to your house and put a new camera in place.
You're gonna see us both on the same stream here pretty soon. But cool, awesome.
Yeah, it's good job on the WASM stuff. That's very interesting and confusing.
Well, yeah, it might be instructor error there, but I can once we get the blog post together and the repo open source, we can take a closer look. There's also a ton of cruft in there that I did not rip out, so that probably did not help.
Yep. Okay, cool. Well, see ya on the next stream. Probably not next week. Next week is a holiday here in the US, but maybe the week after we'll try that. Although you and I will be potentially touring a lab locally too, so we'll see. We'll see the next time we do this.
Yeah, that's in the morning, or no, that's in the afternoon now. Never mind. So
yeah, I think it's in the afternoon.
Anyway, we'll figure it out.
Yeah, totally. All right. Thanks everybody for watching and attending and asking questions. And if you're watching this after the fact, you can always check out our forum.goliath.io, and ask us stuff over there too.